Let's solve this 10 marker mechanics question. When building a lean-to tent, a user places a log XY modeled as a uniform rod against a fixed smooth horizontal branch at B. The log XY has mass M, length 4A, and rests on rough horizontal ground. Because the rod is uniform, the weight will act at its midpoint. So let's annotate the weight over here, which would be mg. Since the length is 4A, it would have a distance of 2A on either side. B is at a vertical height 2A above the ground and in a plane perpendicular to the vertical plane where XY lies. This just means that branch B is sticking outwards. The log is inclined to the horizontal at an angle theta, where cos theta equals 3 over 5. So I'm going to draw my triangle quickly, have my adjacent and hypotenuse 3 and 5, so that means the opposite is 4. So sine theta is 4 over 5, and tan theta is 4 over 3. And the coefficient of friction between the log and the ground is mu. Given that the rod rests in limiting equilibrium, find the magnitude of the force exerted on the log by the branch at B. So if it's in limiting equilibrium, we know that on the ground we've got the maximum friction acting, and we've got a normal contact force over there. We also know that we've got a normal contact force over here, which we'll call N, and because the branch is smooth, there's no friction. So the question is asking me to find the normal contact force at point B. I don't know forces at 2 points, X and B, so in this case, I'm going to take moments. In these types of questions, the only things you can do are take moments or resolve forces. So for part I, if I choose to take moments about point X, because I'm not sure what either of those forces are, we'd say moments about X. The sum of clockwise moments is equal to the sum of anti-clockwise moments about the point. So if I look, where are my clockwise moments? I've got a force here. This is going to be my clockwise force. So the equation for moment is force times perpendicular distance from the force. So the force is mg, and the perpendicular distance I can use trig to calculate would be this distance over here, x. This would be theta, and I know that this is 2a. So this would simply be 2a cos theta. And that's equal to the sum of the anti-clockwise moments. This is the only anti-clockwise force. So the equation would be force times by the perpendicular distance, which I can do triangle again over here. I've got a height of 2a, and this would be my perpendicular distance. So this would be sine theta equals 2a over x. Rearranging, I get x is equal to 2a over sine theta. Now, if I just sub in my trig values, which I know, I get mg, 2a times cos theta is 6 over 5a, which is equal to n multiplied by 5 over 2a, if we sub in for sine theta. Now, I can cancel out my a's, and if I divide through by 5 over 2, I get that n is equal to 12 over 25 mg. And that is the answer to part 1. Part 2, find the value of mu. To find mu, I'm going to resolve my forces. So mu is in the friction equation, which acts horizontally. So I'm going to resolve horizontally first. So resolving horizontally, I'm going to take the right direction as my positive. We have that friction is equal to the horizontal component of n. So if I just add angles here, this would be theta. So this angle here would be 90 minus theta. So the horizontal component would be cos of 90 minus theta. So I have that mu r, which is the equation for friction, is equal to n cos 90 minus theta. I have n, but I don't know what r is. So to find r, I have to resolve upwards, and I'm going to take the upwards direction as positive. So looking at my diagram, the upwards forces, I've got r plus the upwards component of n is equal to mg. So this would just be r plus n sine of 90 minus theta is equal to mg. So r is equal to mg minus n is 12 over 25 mg, and sine 90 minus theta is just cos theta. And if I substitute in for cos theta and put that through my calculator, I get 89 over 125 mg. So now I have my r value. I can find what mu is by resolving horizontally. So resolving horizontally again, mu is equal to 12 over 25 mg, which is n, cos 90 minus theta is just sine theta, divided by r, which is 89 over 125 mg. My mg's cancel, and my sine theta is 4 over 5. And if I multiply that, I get 48 over 89, which is equal to 0.539 to 3 significant figures as my coefficient of friction. And this is how you'd solve a static rigid bodies question for 10 marks.